This video tutorial is for background noises and matrix peaks removal. This module is located within the image visualization section. If you are starting directly from this section, you will need to upload the RDS file in the Upload MSI Data module. Alternatively, if you have already uploaded the data, you can directly go to the Remove Background Noises and Matrix Peaks module. For more information regarding how to upload RDS file, please watch the de-isotoping tutorial video. In this demonstration, I will showcase how to remove matrix peaks using a MALDI dataset where 1,5-diaminonaphthalene (DAN) is employed as the matrix. There are 4 parameters in this module. The first one is MZ value. It only accepts a single value. It can be either a matrix peak or a background noise peak. Here I enter a DAN matrix peak 157.07602. Since the distributions of different matrix peaks are highly spatially correlated, we can employ spatial correlation analysis to identify and isolate all the peaks derived from DAN matrix. Spatial similarity is a parameter that quantifies the level of similarity between the spatial distributions of different matrix ions. Through experimentation, we have determined that a spatial similarity threshold of 0.9 is effective in identifying all the peaks derived from the matrix. Similar as discussed in de-isotoping module, decreasing the spatial similarity threshold can increase the number of detected matrix peaks, but it may also lead to the inclusion of some false ion signals. Conversely, raising the spatial similarity threshold can reduce the number of detected matrix peaks. It is important to strike a balance based on your specific requirements and consider the trade-off between sensitivity and specificity. The other 2 parameters are subset the MSI data by selecting every nth pixel and the number of workers. They are both optional, and they are used to enhance processing speed. These 2 parameters have been discussed in Data Preprocessing module. Please watch Data Preprocessing tutorial video for details. Once you have set the parameters, you can click the Start button to initiate matrix peaks removal process, and you will receive the results shortly thereafter. You can see that there are 63 features are identified as DAN matrix peaks, including the isotope peaks. You can then click the Delete button to remove these DAN-derived peaks, or you can click the Reset button to restore the previous state. This will allow you to reperform matrix peak removal or skip this module altogether if desired. Before removing the identified matrix-derived peaks, it is recommended to examine their distributions. You can visualize the distributions of several of these peaks, and verify if they exhibit a highly similar spatial pattern to the entered MZ value. This step ensures that the identified peaks indeed correspond to the matrix compound and can be confidently removed. The process of removing background noise peaks follows a similar approach to that described for matrix peaks. You can input a known background peak, such as a peak distributed outside the sample region. By identifying and analyzing other peaks that exhibit high spatial correlation with this background noise peak, you can effectively remove the unwanted noise peaks from the dataset. It is important to note that this step can be performed several times in order to efficiently remove various noise sources. Another useful tip for effectively removing background noise peaks is to utilize the View MSI Images module. This module allows you to examine the spectra from various pixels in the MSI data, including those outside of the sample region. By analyzing these spectra, you can identify background noise peaks. Once identified, you can return to the background noise removal module and proceed with their removal accordingly. For detailed instructions on how to view MSI images, please watch View MSI Image tutorial video.